These notes are over patterns and sequences. So we're kind of switching gears from our proportions and our percents, and we're moving on to something that involves some algebra and some expressions. So first, let's talk about some vocabulary. Our first vocabulary word is sequence. And a sequence is kind of self-explanatory if you know what it means to have something in sequence. But a sequence is an ordered list of numbers. An ordered list of numbers. So for example, 2, 4, 6, 8 would be a sequence of numbers, and that sequence could keep going. The position of the term is a term's position in the sequence. A term's position in the sequence. So 2 is a term, and 2 is in the first position of that sequence. 4, the term 4 is in the second position, and the term 6 is in the third position, and so on. So the position of the first term is 1. And position of the term is always represented by our n. N always is going to equal the position. And that will make more sense in a minute. The value of the term is the value of an expression at a given position. And if you remember, an expression has to have at least one operation, and in our case, it will also include a variable. So an expression is going to have an operation, which means add, subtract, multiply, divide, something like that, and a variable. So the value of the first term is 2. The value of the second term is 4. And the value of the third term is 6, and so on. So the position is always going to be 1, 2, 3, 4. We always start our position at 1 because we have to have a first term. And then the value is going to be whatever is created by that expression. The common difference is the difference between two consecutive terms in a sequence. And consecutive means right next to each other. Consecutive would be like the first and the second, or the second and the third, or the third and the fourth. Those are consecutive terms. And if you look up here, the common difference in this sequence is 2. Each time the value increases by 2. So the common difference is 2. So let's go on to our notes. You can represent terms in an arithmetic sequence with an algebraic expression. And remember, an expression has an operation and a variable in this case. A sequence is made up of a series of numbers that follow a pattern. The numbers in the sequence are called terms. Each term can be identified by its position in the sequence, which is represented by n, remember this n up here, or the nth term. For example, up here in our sequence, 2, 4, 6, 8, we know the first, second, third, and fourth terms, but what if we wanted to know the 250th term? We don't necessarily want to count by 2 all the way up to 250 numbers. So we can use a variable n to come up with an expression that we can use to find the 250th term. And if you'll notice, this is the n. Remember, n is the position, so n is 1, n is 2, n is 3. If n is 1, I want you to be thinking about what we would do to 1 to make 2. And if n is 2, what could we do to 2 to make 4? And if n is 3, what could we do to 3 to make 6? If you'll notice, 1 times 2 is 2. 2 times 2 is 4. 3 times 2 is 6. So each time we're multiplying the position, or n, by 2. So if we wanted to find the 250th position, we could multiply 250 times 2. So the 250th term would be 500. The way that we generalize that, or make our expression, is by writing 2 times n. So our expression for this sequence would be 2 times n. So I could plug in any position for n and find that term. If I wanted the 500th term, I could plug in 500 for n. If I wanted the 600th term, I could plug in 600 for n. And I could find terms all the way up to really high positions that I wouldn't have to just count by 2's 500 times or 600 times. So let's take a look at some examples. Example 1, if you'll remember from our vocabulary, the position is always n. So here, n equals 1, n equals 2, n equals 3, n equals 4, and n equals 5. We're going to use that information to fill in the table. If you look at our expression, it's 3 times n plus 1. So everywhere there's an n, we're going to plug in our position. So for n equals 1, we plugged in 3 times 1 plus 1. 3 times 1 is 3, plus 1 is 4. For n equals 2, we would plug in 3 times 2 is 6, plus 1 is 7. For n equals 3, 3 times 3 is 9, plus 1 is 10. I'm plugging in the position each time. These are my n's. So you can see how n changes as the position changes. 1, 2, 3. So here would be 3 times 4, which is 12, plus 1 is 13. And here would be 3 times 5, which is 15, plus 1 is 16. So you can see how the only thing that changes about my expression each time is the n as the position changes at position 1, 2, 3, 4, and 5. So 4 is the first term in the sequence. 7 is the second term in the sequence. 10 is the third, and so on. So if I were to write out my sequence, I would write 4, 7, 10, 13, 16. That would be my sequence created by the expression 3n plus 1. So let's do the same thing with example 2. Remember, my positions are n. So to remind myself, I'm going to automatically write n equals with my position numbers. The expression here is 4n minus 2. So when n is 1, up here at the first position, we plug in 4 times 1 minus 2. 4 times 1 is 4, minus 2 gives me 2. When n is 2, everything is the same except the position. So we plug in 4 times 2, which is 8, minus 2 is 6. When n is 3, we plug in 4 times 3, which is 12, minus 2 is 10. When n is 4, we plug in 4 times 4, which is 16, minus 2 is 14. And when n is 5, 4 times 5 is 20, minus 2 is 18. So the sequence created by the expression 4n minus 2 is 2, 6, 10, 14, and 18. If you'll notice, our common difference among the terms in this sequence is 3. Each time it's changing by 3. And our common difference among the terms in this sequence is 4. Each time it's going up by 4. That's also what our n is being multiplied by for each expression. So as a rule, the common difference is what n is multiplied by in the expression. And remember, n is our position number. Now, if you'll notice, 3 times n, so 3 times 1 would give me 3, and 3 times 2 would give me 6. So it's not going to give me the exact sequence, but we have to add to it. Same thing over here. If you'll notice, 4 times 1 would give me 4, 4 times 2 would give me 8, and that's not what's happening. So we have to subtract over here. So we may need to add or subtract after multiplying to get the correct sequence. So let's look at some more examples. Example 3, it says to write the next 3 terms in each sequence. Our sequence is 4, 6, and then 8. The next 3 terms, since you notice each time it's going up by 2, would be 10, 12, and 14. And the positions of those terms are self-explanatory. For example, 4
Mr.
is
Farrar,
in
or whoever is
the
in charge
first
of the
position.
BI, please call 5600.
6 is in the second position. 8 is in the third position. 10 is in the fourth. 12 is in the fifth, and 14 is in the sixth, and so on. And remember, these are our n's. When n equals 1, our expression should give us 4. When n equals 2, our expression should give us 6. So we're going to use the table to record what we found out, which is really just copying it over. And it wants to know what algebraic expression. Now remember, algebraic means variable, expression means operation. So we're looking for some operation with a variable. Our variable is n. Can we use to find the nth term in the sequence? And those words, find the nth term in the sequence, are kind of confusing, but all it's asking is for you to find the rule. Find the expression that can give us this sequence if we use n. So let's look at our table, and remember these are our n's. When n equals 1, our term is 4. When n equals 2, our term is 6, and so on. If you notice, each time it's changing by 2. And if you go back to our vocabulary, that is called the common difference. So the common difference is 2. And remember, as a rule, the common difference is what our n is being multiplied by. So our expression has to have 2n somewhere in it. So if you look at our answer choices, A and D will not work because A has 4n multiplying n by 4, and D has 1n, which is just n by itself multiplying by 1. So neither one of those will work. So now we only have 2 options that we have to check. So we check each one. N equals 1, n equals 2, and n equals 3. Remember, we check 3 n's. So then we plug in for 2n because we're checking answer choice B. So 2 times 1 equals 2. That's not our first term, so B doesn't work either. So it should be C. Let's just check and make sure. Remember our n's, we check 1, 2, and 3. And we're checking 2n plus 2. So when n is 1, we have 2 times 1 plus 2. 2 times 1 is 2 plus 2 is 4. When n is 2, 2 times 2 plus 2, which is 4 plus 2 is 6. And then when n is 3, we get 6 plus 2, which is 8. 4, 6, and 8 are the first 3 terms in our sequence, so C would be our correct expression. You're going to spend the rest of the time working on examples 4, 5, and 6 on your own using what we found out in our notes today.